G'day folks. Well, it's time to autopsy the worn out 253 V8. This one came out of a Holden HQ ute. It's been rebuilt by RPM engines. I couldn't find any official designation on it because they've reground the block stamp and just re-stamped it RPM 9753, I think it is. Yeah, something like that. It's just got an aftermarket stamp on it. Sort of unnecessary. It'd be nicer if they'd kept the original stamp, but they've taken the face mill over the whole lot of it and redone it. So yeah, we're going to pull it to bits. For those who've only ever worked on small engines like lawnmowers and things like that, there really isn't an awful lot of difference between a 4-stroke gasoline lawnmower engine and a 4-stroke gasoline car engine. Obviously you've got more cylinders. You do have water cooling, so you've got to be mindful of passages and sealants and gaskets and things. You've got a water pump to circulate the coolant. Apart from that, your ignition system's pretty much still the same, be it a mechanical points distributor or a electronic distributor. You just have a multiple high tension outputs, which have to be timed accordingly. Yeah, I'll dismantle the distributor when I get time anyway, but this one there shouldn't really be anything to it. You just got a rotor button which turns in relation to the camshaft and fires each cylinder accordingly. There's really not much else to it. A condenser in there, just like any other small engine. Set of points like the older style small engines. New ones use electronic ignition either on a car engine or a small industrial engine or mower engine, and it's the same sort of principle. It fires off the coil at a set point, and the rotor button simply aligns which plug it wants to fire. Each of these points inside the cap is connected to each plug, so whatever the rotor button's aligned with when the coil is fired gets a spark, and if it's timed correctly it'll fire just before top dead center on that particular cylinder. So there really isn't much difference in working on one of these than there is working on an industrial engine. They just have more parts on them and a water cooling system. Some industrial mowers and things run water cooling, like the big diesel hydrostatic ones and things like that, but still, you got a basic carburetor. There's not a lot more to these than any other carburetor. They just have a series of jets, in this case 2 of them, float bowl and everything in there, throttle pump, throttle butterflies inside, and a choke butterfly or flap on the top. That's your main choke there. This one's never been run on, or if it has been run on LPG, they just cut the cable off and left the choke off. So yeah, I think it has been run on LPG, but they've left this cut. That explains why I never had to cut this cable. This was like that when I found it. Ignition coils, bit different to a small engine. Small engines use a flywheel energized coil, the magnets and regular coil. In this case this has a 12 volt feed to a resistor which feeds the coil about 6 volts, and it goes to the center of the distributor cap to the rotor button. So every time the coil's fired, the high tension goes through here to the rotor button and then out to whatever point it is aligned with. So it's just fire, 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 or whichever one, yeah. If the rotor's going that way, you go bang, 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 and fire each cylinder, whichever lead's connected to what. Each engine has its own firing order and everything's stamped on it somewhere. That's not it, but there will be a firing order stamped on this engine somewhere. There it is. Firing order is 1, 2, 7, 8, 4, 5, 6 and 3. So that's how you set your leads up from your starting point when you first set your distributor up. Pretty straightforward. Not an awful lot else to it really, but we'll get into it as we tear it apart. Push rods are push rods. Any side valve engine and a lot of the overhead valve engines, or any overhead valve engine, will use push rods. Side valve engines have little lifters, but no real push rods. Yeah. I guess I better get the rattle gun fired up and start just dismantling every little bit of it. There's not much worth salvaging apart from the carburetor, distributor, coil, and I'll have a look at the other bits when I get to it. The fuel pump's not all that old, so I'll keep that. Well, Matty VT93 wanted parts, so he can have that. The other little bits and pieces. Everything else has pretty much had it. The water pump's had it. These things are only like 30 bucks anyway, so I wouldn't bother keeping these. Oil pump is tired, well, it's going to be tired anyway. I mean, it wasn't pushing oil up to the top end, so it can't be very good. The starter motor's ancient, and the pinion, the drive pinion for the ring gear is badly chewed out, so that's not worth salvaging. Yeah, this whole engine's just a wreck. The intake manifold's fate will be determined if there is corrosion around these galleries here. There's cooling galleries that come down through to each end of the head. There's one there, 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 and there. And they're notorious for corroding out between the iron and the aluminum casting. And you end up getting water leakages around here or down into the valley into the crankcase. So if they're corroded and pitted, the manifold's scrap. If they're ever so slightly pitted or not pitted at all, the manifold's okay to keep. But I've got a feeling this is going to be pretty much a scrap job. Okay, I'll slowly get the external components off. Carburetor came off pretty easy. I had that off before to clean it when I first set it up, so just a matter of getting off the top. Used a bit of that Loctite Blue Max sealant, so it worked quite well for the purpose it served. Fuel pump's off, that's somewhere, probably on the shelf at the moment. Distributor seems to be in pretty good condition. It's a Bosch, generic Bosch distributor, Australian made one. Not really any difference between them and any other Holden V8 distributor, I don't think. The oil pump's a standard gear type. This one's probably quite tired considering the lack of oil pressure this engine has always had. I'll get a spanner and just take these bolts out. I'm not going to bother keeping this considering how low the oil pressure on this thing has been. It's sort of like a hydraulic pump. There's a drive in the centre of there. Water pump, very typical of one that's never had coolant run in it. It's just a lump of rust. Bad bearings. Bad seal, it's been leaking out through the seal. This engine was also leaking around the front side cover in here, some of which made its way into the crankcase before I put stop leak in it. So yeah, this engine's had both water through the crankcase and lack of oil pressure, hence the rust in the push rods and things. It's one well used engine. It's not dead, but it's getting close to it, so it's time to say goodbye. Likewise, pitting around the front cover, pitting in there. Definitely not worth salvaging because it's getting very thin, if not all the way through. Yeah, that's all scrap. I've got to try and get the harmonic balancer off next, I think. Also the coil mount and everything, I'll strip all that off. And yeah, I'll get the front cover off. Okay, well the oil pump's definitely not very happy. We've got chips and pits on the gear teeth and everything. Being a gear type pump, they're fairly close tolerance. But this thing's just been sucking in grit and metal debris and other stuff like that. Housing's very badly scored, gouged up. Same with the face of the housing. It's just totaled. That's why there's no oil pressure. The damn thing's been ingesting some very nasty little chunks of material. There's pitting in there, a little dent. Lots of scrapes and gouges. This thing's just been eating itself. Not itself, probably other bits of the engine. Bits of dirt getting sucked in places, rust from the top end, little granules of rust coming off these push rods. Yeah, she's toast. It's interesting when you take things apart, you find out how they died. Oh well, at least I know the oil pump's not worth salvaging. Scrap metal. Now what's next? I guess I better get the front harmonic balancer off, the valley cover and the front cover. And then we can move on to the heads. I'll even strip the rockers off as separate items. Just get the rattle gun out and rattle all those bolts out while I'm at it. Well, I was not expecting the inside of the front cover to be that clean. I haven't cleaned it or anything, that's just how it came off. It's pretty damn good. I guess it hasn't been leaking coolant in there, but you can see how close the coolant galleries get. All the water leakage that I had was probably coming out just down there. You can see it. There's a build-up of rust and some of the stop leak that I used. Front main sump seal there. Actual front main is a lip seal. All been leaking a bit. There's oil. There was oil everywhere when I washed the engine down. But the front cover's not. Yeah, it's getting fairly thin. I wouldn't trust it, especially not with corrosion around the outer edges. Oh yeah, there. That's a failure point, and so is that. Too thin. Scrap metal. The old timing chain. There's no tension or anything on these things. They just go as they go. Yeah. That's the oil pump drive. Oil pump fits on the side there. Oil pump's driven off the camshaft, of course. So that's the camshaft. That eccentric there operates the lever on the fuel pump. Just oscillates up and down, pumping fuel to the carburetor. Yeah, not really much else to it. It's all pretty flogged out due to lack of oil pressure and everything, so it's all going in the scrap bin. Bit of a shame, but apart from being a bit of a noisy backyard toy, that's all this thing's good for. And I don't have room for a noisy backyard toy of this kind. I'm going to use it to make room for the diesel engine. Diesel's much more fun.